This is a test for two means, small independent samples. The problem says a local bank claims that the waiting time for its customers to be served is the lowest in the area. A competitor's bank checks the waiting times at both banks. The sample statistics are listed below. Test the local bank's claim, assuming that the variances are unequal. Okay, the claim is that the waiting time for the local bank is less than everybody else, including the competitors. So we write mu local less than mu competitor. I always like to label or to use notation that it points to what part of the problem you're working on. That, of course, is the alternate hypothesis. And the null hypothesis is just the opposite of that, namely mu local is greater than or equal to mu competitor. Test statistic. The test statistic is x bar 1 minus x bar 2 divided by s1 squared divided by s2 squared plus divided by n1, s2 squared divided by n2. In this case, what we have is we have got the difference of means is 5.3 minus 5.6 divided by the square root of 1.1 squared over 15 plus 1 squared over 16. And the calculation is as follows. Paren, let's clear this here. Paren 5.3 minus 5.6 on paren divided by second square root. 1.1 squared divided by 15 plus 1 squared, which is 1 divided by 16 on paren. Answer is 0.792, minus 0.79. Okay, minus 0.79. Okay, here's minus 0.79. This is a left tail test. Okay, and for the critical value, we go to the t-table. Degrees of freedom are one less than the smaller of the two ends. So here's 15, one less than 15 is 14. So our critical value is going to be for 0.051 tail is going to be, let me point it out to you here, 1.761. And of course that's minus 1.761 because it's a left tail test. And we can see that we fail to reject H naught. Okay. Statement of results. We've got our little helper. And our helper says, first of all, the claim is the alternate hypothesis. We failed to reject. Therefore, there is not enough evidence to support the claim that the local bank's waiting time is less than everybody else. And that's, I think, the way I'll write it. There is not enough evidence to support the claim that the local bank's waiting time is lowest. Let's put it there. Okay. Then for p-value, since we don't have a calculator, pretending, we're going to approximate it using the table. What we do is we look at the 14 degrees of freedom line, and we look over and we try to find out where 0.79 would go. And we see that at 14 degrees of freedom, 0.79 goes between 0.692 and 1.345. Therefore, the p-value is between 0.1 and 0.25. So 0.1 less than p less than 0.25. Okay. That's the job done the hard way. Now, if we look at the easy way, we've got stat, tests. This is a 2-sample t-test, which is 4. And I think the data are already in there. Yes, they are. The first sample mean is 5.3. The standard deviation is 1.1, 15 degrees, and so on and so on. So everything is in there. It is a left tail test. That's why this box is marked. And we said we're doing unequal variances, so let's still go down and hit calculate. And we get minus 0.792. Well, that's pretty darn good, okay? And we get 0.2172. That is about 22%, and that is, look at here, that's right, that's between 0.1 and 0.25. So our calculator verifies that we've done the problem correctly. Now, there's one other thing I want to show you, and that is that the difference between equal and unequal variances tends to be quite small, especially if the samples are of reasonable size and if the means are reasonably close together. About the only time you ever have any trouble. Remember, the important thing here, and this is why some people say don't bother with the more complicated calculation, because the important thing here is whether we reject or fail to reject correctly. So just for record purposes, so you see it, let's look at what we get if we assume equal variances. The difference there is that we go to stat tests, and then we go down here to the bottom. Oops, I missed my test. Hang on a second. There it is. We go down to the bottom here, and where it says pooled, we mark yes. Now, if we do the calculation assuming equal variances, what we get is essentially the same thing. I think it's different in the third decimal place, and I think that the p-value is different in the third decimal place, but not enough to make a great bit of difference, and that's normally the way these things work out.